So, first up we have, sorry this is a bit small, Nikolai Moore talking about creating a test network with namespaces with 10 commands. After Nikolai is Vic Oliver talking about RepRap Micron, the road to nanotech, and after him, Arjun Lentz. All right. Time starts now.
Hi, my name is Nico. I'm a lead software developer at Superloop. And today I'm going to be talking about creating testing networks using network namespaces. I found out after I started planning the talk that it's actually only 8 commands. But first I want to talk about why. So if you're making a networking product, you want to do end-to-end system testing. Obviously you can cover a lot with unit testing, but finally you want to have that set of system tests. And traditionally, this has often been done by attempting to use multiple VMs and having a client and your unit in a test. And it's possible, but it's very hard and it's very slow. And I believe that using network namespaces is a good solution to create a flexible, much more flexible, faster simulation of various network topologies. So here are the 8 commands. I'll go through them one by one. First, you create a network namespace, call it test LAN. Then you create a VIF pair, named LAN VIF and the LAN VIF pair. You move your LAN VIF pair into the test LAN network namespace. Give your LAN VIF an IP address, bring it up. Then you create an IP address for your LAN VIF pair, and you use ipnetnsexec, which allows you to execute any command within the context of that network namespace. And bring that one up, and if you're just doing the simplest possible network, you give a default route out via your network, and therefore you have a simple 10.1.1/0/24 subnet, and that's it, basically. I think I've gone pretty fast, but I think they want that anyway, so. And this gives you lots of options. If you want, you can create a test LAN, a test WAN, and if your product is a router like ours is, you can set up different configs and test that most often for us, it's ping. Ping is a great test. As we all know, if you have ping, you have a network. And this is not my idea. I did not come up with this. This QR code gives you let me Google that for you, PyTest network namespaces will give you lots of blog posts, existing packages that you can just download. I strongly suspect that if you are using other testing frameworks, you can find similar ideas. Thank you for your time.
Well done. He's setting the laptop on full. Yeah. All right, sorry. Next up we have Vic, who's doing one of the half talks. He has 90 seconds, and Arjun will be setting up while Vic talks.
Well, I'm Vic's laptop. Where's the case?
Okay, I'm Vic Oliver from the RepRap project. We did the first replicating 3D printer. The project, and we are doing something called the RepRap Micron, which is basically a self-replicating printer with a 1 micron feature size. That's 1,000th of a millimeter. And we have a project page up on blog.reprap.org. We have the STL files on printables, and we have the software on GitHub. So RepRap Micron, come in, join us, and get some real disruption going. Thank you.
All right, short talk's a good talk. So Arjun is talking about the Haystack log database.
That was some of my time.
Okay, thank you. That was some of my time, which which is how it worked. I thought it was worthwhile. Okay, I'd like to talk to you about this in one slide because I didn't get to talk in, so that's how that one works. The haystack storage system. You want me to do? I'll stay here. That's okay. While I briefly wasn't employed or running a company last year, I wrote a little database storage mechanism. For those of you who are involved with coding and log-based databases, you'll see some keywords that are familiar and can make some sense of it. For those of you who are not, I'll give a bit more information. A log-structured merge tree is, for instance, how Google stores their big table. It's how they structure their big database. But what I do is something extra. So I do structure things in rows, but the rows are actually connected in keys. The keys are connected, but they know which one is the first. So in the end, everything is indexed. It doesn't care what you search on. It can find it really, really quickly. So you don't have to decide what you're going to index up front or add things later, which might make a big difference to what you're actually trying to search. So have a talk to me or look it up online. Thank you.
Thanks, Irene. All right, next up, Steve Dalton, who's talking about everythingopen GPS. So 1 minute to set up.
I'm sure if this doesn't work, just say you've got something to look at while I'm talking. Do we do anything? HDMI? Oh, ooh. Sorry about that. Wasn't expecting that. Right, thank you, gosh. Should have enabled mirror mode. I wasn't ready for that. There we go. So in my day.
You need to stand in front of the lectern for them to hear you.
Yeah, got to do that. Right. Hi, my name's Steve Dalton. In my day job, I work in all sorts of things, including some work with agriculture, with working with farmers, agronomists, if you know what one of those is, a lot of work with mapping, but today I'm going to talk about another project which just started working on, which is called everythingopen GPS. It is a self-steering system for tractors. It's been around some time. It's not a self-driving car. Tractors don't really need to have cameras or anything like that because usually no one's in the field. You need to just drive in a very straight line and you need to make a really good turn at the end and bring down implements and things like that. It's a totally open source project, actually designed and built by a farmer, Brian. It's been around a while, but it's recently had some new boards, some new hardware built, so it's got a really cool all-in-one board they've just built. It's all totally open source. They have really good, really cheap GPS RTK systems now, which has really made this thing now. It's between $1,000 and $2,000 to build an entire self-steering system for a tractor, which would normally cost $100,000, maybe $10,000 if you buy a cheap one, but you're not going to be able to do any sort of modifications or open source things with that. There's some really cool things about it, but also some slightly sucky things. It runs on a Windows machine like this, Panasonic ToughPad, which sits in the cab of the tractor. It's all written in .NET, but it is open source. If someone wants to port it to Linux, I would absolutely love that. But the board itself has a RTK GPS, you can have two, has an IMU, really awesome IMU for like $20, which does all the roll compensation. There's a motor driver, which turns the steering wheel. You can see here 3D printed cogs on steering wheels. Sometimes they even turn them with rollers. And because you've got power steering on the tractor, you don't actually need to turn the steering wheel very much to make a turn, which is quite clever. Runs a Tinsy board on there as well. So that's all I have to say about it, really, apart from I'm only just starting, so I'm only kind of a newbie too. If anyone else is involved in everythingopen GPS or wants to be, or especially someone who can port .NET to Linux, I'd be really interested to talk to you. The project itself is mostly built by farmers. The project, it's very obvious that it's written by farmers because the doco is a bit crap, but I'm so impressed how many farmers have actually built this and contributed to this all over the world. That's Open GPS. Thank you.
Did say Fast Talk was a good one. So now Geordie Miller talking about Radio Console, an open source touchscreen radio controller. And next up, Alistair Chapman.
Yeah, there we go. Okay, yeah, that sets the mood for this, doesn't it? Yeah. Sorry, I've got no presenter notes. Yep, that's better. Okay, yeah, that sets the mood for this. But one thing you're going to notice, remote areas are great for getting away from it all. But one thing you're really going to notice when you do go to remote areas is they're pretty remote as you travel through them. There's a definite lack of infrastructure out there. It's not a great deal of anything. So that certainly leads to a definite lack of internet infrastructure out there. So really the logical conclusion is that for the sorts of people we are, you'd kind of want to bring your own. So that's Telstra's 3, 4 and 5G coverage map, 3G to end soon. And well, you can see there's a lot of empty space there, even if it does look pretty well covered up the east coast. For the kind of area we were in, satellite only pretty recently practical and not really usable in a moving vehicle quite yet. That has improved a bit. That's what the coverage map looks like now, and there is a variant of the dish that will work in a moving vehicle kind of in some areas where available sort of some of the time. That's improved, but the cost certainly hasn't. So HF radio bounces off the ionosphere, which is not yet a commercial service till someone figures out how to fix that problem. And so what you do is you build the rolling cactus. 3 antennas on the front, 2 more on the back. Bit of a link up there to a video that talks more about that in depth if you've got 20 minutes to lose.
1 minute.
And so what can we do? Video from my partner on this in more detail, but text messaging, position updates, email over radio, paging, notifications, all open source. Proprietary stuff has no, should not belong in amateur radio. What's it all on? A Pi and a GPS in the back of the car. And then the problems begin. The trouble is, if you're going to do stuff like this to it,
30 seconds.
What do you reckon's going to happen? So then you can see that's just spewing stack traces, USB's gone offline. So how the hell do you monitor all of this stuff and, you know, have a PAN adapter for the radio? Well, radio console, written in Pygame, strange choice, yes, maybe. Lots of reusable components, brief live demo. Here it is off to the, oh, that has not liked switching monitors.
5 seconds.
But there it is, PAN adapter, GPS panel. We've got primarily...
And
log
time
viewers.
is up.
Yeah, final slide. If anyone
No,
wants to...
time is up.
There we go.
All right, I don't make the rules, I just stand here and, you know, annoy people. So, Alistair Chapman, using WebAssembly to run code in too many places, and he doesn't even need a minute.
Assumption.
And next up, Michael.
Winning from the desktop comes to save us all. All right. Well, everyone, I'm Alistair Chapman. I don't have time for intros. I'm moving on to this. I just want to talk about WebAssembly. To be clear, I'm not an expert at WebAssembly. I just tried using it once, like 6 months ago, and thought it was pretty cool, and have just fallen down a few rabbit holes along the way. For those who do not know, WebAssembly is a compact bytecode format you can compile lots of languages down to. Originally designed for running code in the browser, Mozilla came up with it, everyone else nicked it. That's the way the web works. And it was immediately repurposed for things it was never intended to do, which is also how the web works. That led to something called the WebAssembly System Interface, or WASI, which was basically taking this very useful web-native technology and then just smashing it onto anything that can run code. It has a whole standard API spec. It's a whole thing to fall down. And it does introduce the wonders of browser incompatibilities to the back end, which is what we've all been waiting for all these years. You can build and run lots and lots and lots and lots of different things into WASM. So if we have a quick demo that I'm not doing live because I'm not insane, here's some Go code that is just plain basic Go code that if you run it through Go, runs perfectly normally, but you can also run it with their fancy WASI P1 target, and then it goes through a WASM runtime, that in my case is WASM time, and it's running through this fancy WASM binary module to show that it's running WASM instead. Now, that's pretty neat, but you can also run it other places. So most of, basically any recent version of Podman and anything that uses crun can also run WASM workloads directly. So you can do things like, here's some .NET code that runs perfectly. That after I build it, I can run it directly through the .NET runtime. It's running natively, that's fine. It also outputs a WASM sample.wasm, which we can run through the WASM runtime. And now it's running the exact same code, but through WASM on the desktop. I can then also run that through a container file. You can see the from scratch there. There's no Alpine, there's no UBI, none of that. It's just running the WASM workload directly on, in this case, WASM Edge through Podman, which only got added a little while ago, so it doesn't need that fancy annotation on the end. But you can run a workload directly in a WASM runtime running on top of Podman. Oh God, that's really bad news. It does mean you can create some truly cursed shit, like crossing language boundaries that were never supposed to be crossed. So you can do things like this, which is I have a JavaScript file, because we all love JavaScript so much, that I can run through a framework called Exism. That's an open source WASM-based thing. We don't have time. And it compiles it into a WASM module. I can then also take that same Go code from before, change the functions around to use this fancy Exism framework. Both of those will dump out
30 seconds.
Oh God, standalone WASM files. I can put those standalone WASM files, wire them up to .NET, and now from .NET I can load JavaScript and Go code from a JavaScript module, run it through the .NET runtime, publish that to WASM if I want to, and layer languages inside each other like some truly horrifying human centipede. But it does mean that if theoretically this should just nail the timing, when this runs, you'll be able to see the .NET runtime loading Go code and JavaScript code out of WASM modules and running them locally on the desktop, which means you can create all sorts of truly horrifying creations that you can never debug.
All right, Michael De Silva.
Just fall off that one.
Thank you.
Where you go?
Hey guys, I'm Michael. Apologies, I have to use the corporate slides template, so suffer. I work for Arnet. I'm a software engineer and sysadmin kind of guy with a researchy background. This is my second conference. So File Sender, what is it? It helps people share large data sets over the internet. It's a big deal in Euro research land. There's at least 50 deployments worldwide. File Sender is fully open source, and there's a GitHub link. Click, click. It basically lets you forget about email attachments. Transfer is using SSL. There's end-to-end encryption, so it's all encrypted on disk. It's got a really nice user interface for non-techie people, and then the diehards get a CLI tool, which also helps with automation. So the academics like it because they can share research data. If they go to a research facility, run a detector, hello, synchrotron guy, send their data back home. Corporate land likes doing security data back and forward. The entertainment guys do the HD video transfers across the country. I work at ARNet, so we do one for researchers. It utilizes our fast network. It also complies to all the data sovereignty and privacy things I don't really care much about. It provides single sign-on using the customer's identity provider, so we don't have to worry about auth and passwords and things like that. It all comes from the customer's IDP. Our end-to-end encryption uses the AES 256.
1 minute.
We limit 1,000 files, 10 terabytes per transfer. AI Bing, thanks. That's the interface, yay. What is it actually? Well, you know, dad joke, everything open source. Basically the software stack, everything's open. That's the workflow, but I can't be bothered, and I have, 30 seconds? So, yep. So there's the link again. Get involved, download it, install it. It's really simple. Or, you know, if you're one of our customers, it's free. It's already there. Go use it. And yeah, thank you, Gladstone.
All right, thank you, Michael. And our final talk is Justin Stewart, who's telling us about shiny, blingy things.
Hey, there we go. Forgot about a lack of adapters on this laptop. So, I have tiny magpie brain and like shiny things. And a few years back, I suddenly had a lot more free time on my hands, so I decided I would start making my own shiny things. It often comes up in conversation because I wear a lot of it all the time, and one of the things people often ask me is, how do I actually do this? But I bought some pliers. Still got those pliers, 5 years on, and they are still the best pliers I've bought. You know, pliers alone aren't enough. You also need a whole bunch of tiny little metal rings, and the internet to tell you what patterns to make pretty patterns. That's not enough rings to really make anything, but that is. But all good hobbies escalate, and that's aluminium, and I had a friend turn to me one day and say, you should make me something, but also your stuff is too shiny, and also I like spikes. So there's a bunch of the aluminium stuff. And then I started playing with stainless steel. It's a lot less forgiving. It's a lot harder a metal to work with, and I need some padding on my pliers. And some more stainless steel, because I bought a lot of that too. But all good hobbies need to keep escalating. So I kept the shiny things going by buying some shiny rocks. What do you do with shiny rocks, though? Jump rings don't really work for that. So I bought a whole pile of...
1 minute.
Time goes fast. A whole lot of copper wire and silver wire, and started learning new skills. And eventually, you know, nice shiny silver pendant on an aluminium chain. Time to start escalating the hobby again by buying some little metal rods to accidentally create springs, and
30
discover cutting
seconds.
springs with a saw. Really need safety glasses, because when saws break, metal flies everywhere. Sometimes projects fail, and if anybody wants to come and help me organize my craft space, I would really appreciate some help. Yes, thank you. Sorry? No, I have avoided an Etsy store. But I will trade jewelry for free stuff.
And time is up. Thank you. All right, so that was our last talk. I'm not really sure what's happening now, but presumably a core organizer will turn up and put me out of my misery. In the meantime, so yeah, closing thing coming. I'm getting stage directions. In the meantime,